Alright guys, here we go. Section 2 of Chapter 3. Two parts here in this video. Part number 1. In Chapter 3 we're going to talk about is this. We're going to talk about how do you prove triangles congruent. And then specifically in this video, short video, we're going to talk about something called the SSS. No, I'm not stuttering. It's 3 S's and they stand for something you'll see here shortly. Now let me set the stage for you here, and trust me, this is actually going to be a really cool analogy. I don't know if you guys know what trusses are or not, but if you know anybody in construction, they certainly know what trusses are. They're the things that just popped up on your screen. They're big triangular things, and you can see, this is cool, man. They got some cool names for trusses. Look, a double fink, a double how, a modified fan, aka triple fan, whatever. These are the triangular things that go on top of your actual roof. Whatever house you're living in, most likely it has trusses on top of it, where your attic is. So you can see they look like this. This is actually my cabin that we were building over the summer. Totally kidding, but this is a cool cabin. But look at all these little triangular things. So there's one, there's a second one, there's a third one, there's a fourth one, there's a fifth one. They're all on top of this roof, because what happens when you create these triangular trusses so far apart, you then put the boards down and all the other stuff. I'm not going to try to sound intelligent with construction, but I do know that's what they look like. And I know then they put the shingles on top of that. So it creates the foundation of your roof. Now here's a blast from maybe your past, don't know. Good old Bob the Builder. He raises his hand and says, I have a question for you. Can we build this? He says on his left, he has a triangular truss, and on his right, he has another triangular truss, and he says, boys, can we make this particular roof? And of course, you're going to hear is Scoop, Muck, and Dizzy, and maybe even Gripper and Grabber. Well, Gripper and Grabber will probably say, well, hold on there, partner. We got to check something out. And it's true. You can't just hoist these triangular trusses up on top of the roof until you verify one very important thing, that these triangles are even congruent. You certainly don't want to put these triangles up on top of the roof and then one be smaller than bigger than the other one and one side smaller than the other one. Your roof would look ridiculous, and plus your roof would probably cave in. You want them all to be exactly the same. So how will we know if they're the same? That is the question. How would we prove, aka how will we know, that these triangles have the same size and shape, that they're congruent? Well, here's all you know at this point. You know the definition. Certainly, let me move this down. You know the definition. Hello, there we go. So here's what you know at this point. Two triangles are congruent if and only if, remember that's what this symbol means, all pairs of corresponding parts are actually congruent. That would mean this. That would mean Mr. Bob Builder or Scoop, Muck, and Dizzy and all these other guys, they'd have to take this particular ruler and they'd have to measure this side right here and say, okay, that side right there is 20 feet. And then they'd have to come over here and take this ruler and measure this side and say, okay, well that side right there is 20 feet. Sweet. And then they'd have to do the same thing. If we're verifying all pairs of corresponding parts have to be congruent, I got to measure everything. So if I measure this side over here and say it's 10 feet, and I measure this side over here and say it's 10 feet, great, so far so good, because the corresponding pieces match up and they're congruent. Then let's say that this one happens to be a little off, who cares? But let's say that it's 11. Awesome. So there you would have, actually let's do this. Let's make it a little better. Let me erase, we'll say they're 10, I'll just change it. Let's make it nice. Let's make them an isosceles triangles. So let's say that that's great. Now, is that enough for us to know the triangles are congruent? Well, according to this definition, no. We have to verify all pairs, which would then mean this. Goodness, we got the sides. It would mean we're going to have to get out our handy-dandy protractor and measure the side, or the angle measure. So you have to take and measure this and make sure that this angle is congruent and make sure that this angle is congruent to this angle up here, whatever the measures, and then you have to make sure that this is actually congruent to this side over here. It seems like a tremendous amount of work. Let me put the tick marks in. This side would be congruent to that side. This side would be congruent to this side. Whew. And this side, man, I'm getting sick of writing all these things. But you get the idea. So in order for me to know that two triangles are congruent, according to the definition, I would have to verify all these pairs of corresponding parts are congruent. Now hopefully, Scoop, Muck, Dizzy, Gripper, Grabber, someone says, wait a minute, Bob, there has to be a shortcut. There has to be a shorter way. And for your sake, there absolutely is. And in fact, the shortcut is actually on your foldable flappy. Haha. So on your foldable, you're going to see that there's 1, 2, 3, 4. This one down here is kind of cut off, but there's 5 shortcuts that you're going to be able to use to prove triangles congruent. And as I already told you in the essential question, the first one we're going to talk about is this thing called the SSS postulate. And all I want you to focus on, though, is this. Back to Bob the Builder. Let's say that Scoop, Muck, Dizzy, Gripper, Grabber, doesn't matter which one it is, they say, wait a minute, let's forget this protractor even exists. Let's just use our ruler. And is it enough for us to know if I would measure just this side right there and that side right there? Let's say, again, back to my example, say it's 20 feet. So that's 20 feet and that's 20 feet. Is that enough for us to know, hey, that's all we have to measure, guys. Those are 20 feet. Hoist those babies up. We're good to go. Or do we have to actually verify a little more? Is one side enough? Don't know. Maybe two. Don't know. Maybe three. You can't do any more than three sides because that's all a triangle is. So let me show you how this kind of comes about, and we'll answer the question. Can we only have one pair of sides congruent? So is this right here enough? Or do we actually have to say, wait a minute, let's measure this one and make sure those two are equal. So is two sides enough? We'll find out. So let's do it. So on the SSS postulate flap, when you flip up everything, you can put this example in there. It's a very simple one, but here's the scoop. What I've done, I've created two triangles where AB, which is this side right there, is congruent to that side right there. So you can see I have one pair of sides that are exactly congruent. Now here's the thing. If I took this particular triangle right here and put it right on top of it, there you go. That is exactly what congruent means. They line up angle for angle, side for side, point for point. However, here's the scoop. Can I... Scoop, Muck, and Dizzy. That's funny with Bob the Builder. I didn't do it on purpose. Whatever. Keep going. So if I take this point, though, watch this. If I take this point and move it here, notice this. It doesn't matter where I move this point. Notice this distance from F to E is not changing. It's still congruent to AB. It doesn't matter what I do with this thing right here. And here's the point. If I take this triangle now, can you even do this? If I take this triangle, it's not even close to the same size and even shape to the one on the left. So therefore the triangles are congruent. So what am I showing you all this? If I have two triangles where I only have one side congruent, that's not enough for me to know for a fact that the triangles are congruent. Now could they be? Sure. But I need to verify a little more. So Bob the Builder, you better get out your little ruler and verify some more things. So let's go back to this. Let's say, well, hold on. Redo. So let's say this. Let me measure this side. I'll take this side and measure them. And let's see if they're congruent. They should be. So there's my length. So there we go. So, whoops, sorry. Let me switch these around. So AC, there you go. AC is 6.57, whatever. And FD is the same. So we have two pairs. One pair of sides congruent, another pair of sides congruent. And yes, I could put them right on top of each other like I did before. Nothing's different. But here's the scoop. Is there any way for me to keep this one 6.57, but make it that it isn't congruent to this? I don't know. Let's see. Let me move this over here. I'll put it right there. Bear with me. I'll get there. There it is. So you see 6.57, 6.57. That means this. These guys here are congruent, and FE, this guy, that guy, and AB are congruent as well. But I just showed you an example of where this triangle right there is certainly not congruent to this triangle. So if I have one side and a second side congruent in triangles, it is not enough for me to say that the two triangles are congruent. So apparently I need to go one step further. I have to actually verify all three sides of my triangle are congruent to make this work. And that is absolutely the truth. So there is your shortcut. One side is not enough. Two sides is enough. You have to show three sides of one triangle congruent to three sides of another one. And that, ladies and gentlemen, is our shortcut. So back to the foldable, here you go. Inside that particular foldable, we have finally the winner. We got the winner being three sides, not one, not two, but three. And Bob the Builder says, thumbs up to you. We can build it. Let's rock and roll. So here's the exact wording of what the SSS, I call it the S postulate. Okay, just kidding. SSS postulate says. It says, and this is what you need to write in your notes, if three sides of one triangle are congruent to three sides of another triangle. Doesn't mean all three sides are congruent to all three sides. It means take a pair, make sure they're congruent. Take another pair, make sure they're congruent. Take the third pair, make sure they're congruent. If that's the case, bam. Then you always know, always, that these two triangles are congruent. So there is shortcut number 1. Congratulations, there's 4 more to go.